All right, welcome to the after work video. So we've still got one more part left to the setup where I just try to do it all by memory. And then in the next video, I grade myself. Hopefully I can just finish the whole thing in this video, but if not, that is okay as well. So I will share my screen. And I had GNS open the whole time, but you can see, oops, well, you could have, okay, so now you can see, yeah, it's got these timeout. That's because of that cron job it rebooted. So I'll just shut it and reopen it. Yep, and as far as I know, I'll probably need to do another video on this more in detail. But my plan of taking the day off Friday and flying to Sunnydale, California, going to the test center in a mask, renting a car. As far as I know, that plan's going to still be good. But as I said, once it gets closer, I mean, obviously I won't be able to have a whole video where I just go and register because I'll need to like pay the fees and stuff. But I can definitely be as transparent about that process as possible. But for now, let's see if we can finish up the config on this. So in the lunchtime video, I did pretty much finish everything. The only thing I didn't finish is the policy that leaks routes from level 2 to level 1. By default, routes are only leaked from level 1 to level 2 without extra configuration. So let's verify that. Let's go on to level 2 and let's see if we've got these other routes like the loopback address, this /32 or .32/30, this .28/30. Let's see if those routes are showing up on router 1 as we would expect them to do, because routes from level 1 are automatically leaked to level 2, of course, or if it's accurate what I read before. So show route, protocol ISIS. Yep, so that's good to know. We've got the /32, so we've got 1, 2, 3, and we've actually got 4, which is interesting that we've only got 4, but let's see which ones they are. They're this one, well, let's do them in order like this. So this one here, so that's going to be /24. So it's this network here. Okay, yeah, that makes sense because these are going to be overwritten with the directly connected routes. So you're not going to have an ISIS route. So you're going to have 1, 2, 3, 4 routes. So one thing you might notice as well is we don't have these loopback 0 routes. So that's because I did not include them in the protocol configuration. So I will add those because I do want those to show up. Okay, so set protocols ISIS. Oh, okay, I'm already in there. So set interface LO0. And let's see what happens. Yeah, so let's make that a passive so that we're not, so that it's more clear that what the intent of that is. And the intent is to not run ISIS on that interface, but to advertise the subnet associated with it. So let's add that to all of the routers. Oops, I don't want to make this a passive interface. So I'll just hold on to this command so I can just paste it into the other ones. All right, so let's take a look at the routing table again on router 1, filtering out only for ISIS routes. So we can see we've got the routes now. We don't have .3 because that's the one on router 1. The routes are kind of strange because they're matching the host names in the topology here and not what I used, but it's not too unintuitive. And you can see in this case, so here where we only had, so I was going to make a point that, because we've got 1, 2, 3, 4 loopback addresses, and we've got 1, 2, 3, 4 of the interconnect addresses. But yeah, I was just going to make the point that we are going to be learning the loopback addresses from R5 and R4, even though you might think, oh, well, it's the direct neighbor. You'd only need to know these. Well, no, it's not a direct route because R3 has no way to, R3 does not have this /32 configured on it in any manner. In fact, that's impossible since the /32 is just one address. But this /30, it is configured on router 3. If we look at direct, or sorry, if we look at local, yeah, if we look at direct, we've got .16 and .20. So that is why we don't have ISIS addresses for that, because we've got the administrative distance here being 0, but the ones learned through ISIS are higher. They have 18. Okay, and I also wanted to look at the local routes just to kind of as proof that there are host addresses from these subnets locally configured on this device. Okay, but let's go back to the ISIS routing table, and we can see we've got 1, 2, 3, 4, 5, 6 routes that came in from level 1. So we've got all of the loopbacks except for the one for router 4, and then we've got .32, which is here. We've got .36 here, and we've got .28 here. So these are all from area 1. And it's kind of interesting because I just think it's interesting that you have a route here that's all, not area 1, level 1, that's, as far as I understand, completely contained to level 2. So maybe I need to make it a level 2, level 1, but we'll see how my configuration differs shortly, perhaps in the next video. But oh, this is interesting. It's interesting that I've got a cost equal path here, because I would think that for .24 4. Oh, no, of course, I am going to have a cost equal path. You can see there's no difference going boom, boom, or going boom, boom. It's still, it kind of looks, it can be a bit deceiving to look at the topology and see, oh, here's a big long cable, here's a short cable. This is obviously the only route that's going to show up. No, that has nothing to do with the actual technical underpinnings. It's just a diagram of the topology. The paths through from here to this network and here to this network, those two paths are cost equal. And we can see that because they are showing up that way in the routing table. Okay, so let's jump over to router, let's just go right to router 5, the very last one. And hopefully, if it works the way I expect it to work, otherwise I will be very confused and maybe a little bit upset. You might see me freak out. Let's make sure that these loopback addresses and then this address here do not show up in the routing table on router 5. I'm not sure about these. I'm guessing they won't show up either. I'd be willing to bet at this point that I would only see these 2 loopback addresses here and then this address here in the routing table for router 7, because all of these are in level 2 and level 2 cannot leak to level 1 without extra configurations. So let's see if that's the case. Perfect. So, yep, we've got everything good to go. Just as I predicted, .28 is there. .5 and .6, just as I predicted. And then we can see, just like on router 1 in my topology, router 3 in theirs, there is a cost equal path to one of the networks. So one thing that's really interesting, first of all, to notice is that it's a different administrative distance. It's now 15 instead of 18. So that's a big thing that jumped out to me right away. The other thing to notice is the metric is 10 on these, but it's 20 on this route. So I'm really not sure what the difference is. So this is the .28 route. So it's coming from here. So it's got a different metric. So let's go over to router 4 and see if the .36 also has a metric of 20. Yep, so .36 has a metric of 20, and it's a cost equal path, just like on the other side. The final thing to notice that is really interesting, and perhaps the most obvious thing to notice, is the default route that has been sent down via 001. So let's take a look at the interface descriptions into a pipe match 001, and I have a feeling that it is going to be received from router 3 in my topology. Yep, so router 3, it looks like, has some automatic way of sending a default route down to level 1 when it's configured to have both level 2 and level 1 adjacencies. And we can see that is the case. We've got level 2 adjacencies to this side with router 1 and router 2, and level 1 adjacencies to this side with router 4 and router 5. Okay, so some way, somehow, router 3 is able to know to send a default route just based on it being connected to multiple levels. So because of that, we can ping to any address on router 5 as well as router 3. So let's try that. Let's ping to 192.168.0.3. Yep, so no problems at all. Let's do a trace route. All right, so now let's go through and where we did the trace route, let's look at the decisions each of these devices had to make based on its task of routing a packet sent to this destination address. And we could look at the source as well. Why don't we do that actually? So let's go here and let's do let's see what the router will need to do if we send it to when that is being sent to the destination. So we can see it's going to use an ISIS route. Well, let's start all the way from the beginning here. So let's do show route. Okay, so here it's using that default route. So let's continue here, and yep, now we can see it's using the ISIS route. So here it's going to be using local routes or directly connected. Yep, directly connected via router 1. So let's take a look at what happens when it comes back. So by default, the source address is based on the selection rules. So it's going to be using the source address based on what is configured on this interface. So this is going to be the source address. So let's now go to the other side and look at how the ping and the trace route comes back to the device. Okay, so it comes back because it has this ISIS route with a administrative distance of 18. So then it will make it to router 5. Oops, so I want to search for the administrative distance. I want to search for the IP address. There we go. Okay, so now it's got a directly connected route. So a much easier way back because it's just using the directly connected route for the source address. It's going to be a little bit different if we specify the source address to be the loopback address. Let's see what that would look like on router 5. Notice I'm on router 3. That's because my lab topology is 2 fewer than what is here for each router. So if I were to be going back to the loopback, then I would use a ISIS route I learned with administrative distance of 15. Oh shoot, and it's raining again. I wanted to go outside after this video, but I can't. Oh yeah, quarantine is, I thought I was winning quarantine by like staying healthy, but my scale disagrees with me. So not being able to go out and exercise a bit is definitely a bad thing for me. So let's stay focused on this test here because I'm going to be flying halfway across to the other I'm in Central America, well, I'm not in Central America. I'm in North America, but I'm in the center of North America, and I'm going to be flying to the very edge of North America, and then back to the center, just to take what is widely considered to be a really difficult exam. And my expenses aren't going to be reimbursed. I don't even work in ISP anymore. I don't even work with Junipers anymore. I work more enterprise now. But daggone it, I think I'm going to do it. But I'm just going to do it once. Now, I think if I had stayed at my previous job, I probably would have done a second attempt. But with this one, I think if I end up failing it, this channel will just be all I have to show for it. And then I think I'll continue doing lunchtime and after work videos, but I'll do it for things that are going to be more valuable for me in my career, not, paying money to torture myself. Instead, I'll be maybe just buying like Kindle books and working through those. I think that'll be much more valuable and much more economical, that's for sure. Okay, so let's work on leaking those routes now. So obviously it's going to be on router 3, and we have confirmed that it does work in the way that they had claimed that it would. I don't think I did a ping end-to-end from this side yet, so let's do that. Yep, so I mean, this side, you wouldn't think there'd be issues. I mean, of course, there still could be, because of course we know that if it didn't have this here, it wouldn't be able to go either way, even though routes can leak from level 1 to level 2. Once it gets there and needs to go back, since routes can't leak from level 2 to level 1, it'll be able to get there, but it won't know how to get back. Unless, of course, it has the feature we are seeing here, which it does, to send a default route that tells the level 1 routers where to go to get to level 2. Okay, so, but I think what this is calling for, the reason why you would want to leak the reason why you would want to leak is because you might want a more specific path. You might want, like, for example, once it gets to, like, you might want it to, because let me see here on router 3. Yeah, like on to get to this route here, like .18. You can leak it, and then I believe there's a way you can tell it to go over this link or this link, but you couldn't do that just by this here. So you would need some special custom configuration to get that granular with your config, that specific with how you want your traffic to flow. That's why there's educational material about leaking routes. All right, but let's just, before I go through that material and grade myself, let's just try to figure it out myself. So let's do edit policy options, policy statements, route leak. And then we'll do set, let's make terms, term 1, and let's just edit term 1. We'll do set from protocol, ISIS, level to set, okay, and then we'll do set then accept, and then we'll go up and we'll do a set term to then reject, just so that it's clear more what our policy is doing. We don't have any implicit statements. Okay, so now let's go edit protocols, ISIS. Okay, and now let's do set export route leak. Let's go to level 1 and then let's do set export route leak there. Because I'm just kind of using my knowledge of BGP route redistribution to figure this out. So maybe it's right, maybe it's wrong. I'm not sure. Let's find out. Oops, I don't even have the option to export. So very clearly it cannot go under level 1. What about set interface? Okay, so one thing that was going through my mind just now and why I was looking to apply my export policy to more specific areas, let me just say, at this point, I am very confident that it can be just applied like this. And I will tell you why that is the case. It is because if we look at the policy, so let's do a top and then a show pipe display set pipe match route leak. We can see that we're matching ISIS, yes. So you might think, oh, well, you're going to leak the routes back into level 2 and cause a loop, you know, that would be terrible. Well, you know, you're not, because you're only matching level 2. So then you're okay, well, actually, never mind. Because, you know, that's exactly what I'm thinking is, where am I going to leak these routes? Am I going to leak them back into level 2 and cause a loop? You know, I want to only leak them into level 1. So that's why I was looking to export the routes. But you can see clearly there is some sort of issue. So I guess I'm willing to just try it. I guess I want to see more what the options are for then. Is there a level? Anything specific to ISIS maybe? Nope, don't see anything. So yeah, I think I'm gonna go with this. I'm pretty sure it's wrong, but I've got a half an hour left in this video, so that'll be plenty of time to completely get through the answer key and get a good sense of where I went wrong. So let's do that. This is going to be my final answer. So we'll take a look at the answer key and assign myself a grade. Okay, so we'll start off with writer 1. All right, so this part is just a freebie. You can see they went with descriptions, as I did as well. They included family ISO, as I did, and the family INET addresses. That's pretty much a freebie. You can't really get off the ground at all if you don't do that. So the other thing they've got, as I do, is a loopback address with family INET and with family ISO. They chose a different identifier than I do, but I don't think that makes a difference. If on the exam they tell me to use a specific identifier, I will know to use. Hopefully they will provide that for me. Hopefully it's not, because the CCNA, at least the older versions, sometimes would check your more vocab knowledge, and they would kind of tell you how to do something using jargon terms just as a way to test your knowledge of the jargon. Whereas if they just told you more clearly what they wanted you to do, it really wouldn't be a very difficult thing to do. So hopefully none of that happens on the test. It's a little bit, I think, unfair, because I just don't think making things more confusing is really appropriate at all, unless it's necessary to convey the actual meaning. If you can convey what is needed to be conveyed without making it more complicated, that to me is the way to do it. There's no need to say, instead of configuring an IP address on interface GI0, there's no reason to say enable configure privileged mode and configure terminal into gigabit Ethernet GI/ or configure terminal into the first FPC PIC device. You know, there's no reason to obfuscate the directions on a test, especially if the test is meant to prepare you for the real world, where doing that would cause more issues than it would solve. Okay, so one thing that's interesting is you can see that they actually have this leaking statement on a router that isn't between the areas, the one that's only in level 2. They have a leaking statement on. So that's completely different than how I was envisioning it, because I was thinking it was more like OSPF, and you would do things on the ABR to manipulate how things are sent between areas. You would only need to look at the ABR, but clearly that is quite a bit different. So it looks like, yeah, so it looks like this, they take the loopback address only, because yes, it's a /24, but they, that's interesting, because there are going to be more. So it's taking all of the loopback addresses that it learned, because if I do a show route 192.168.0.0/24 or longer, just as they have it there, I thought I could do that. I can't do it. Well, I think it will show me longer. Yeah, it already shows me longer. So longer, long, short, we're talking about the networking portion of the addresses. So /32, the network portion is longer. It has more bits. It has 32 bits instead of 24 bits. So by default, without specifying anything, you see or longer when you do show route. So we don't have anything for 24, but we do have longer subbit mask portions, the network portions. We're going to have shorter host portions. In fact, we don't have a host portion at all, since this is /32. But we can see this route filter will actually be matching 2 routes. It'll be matching the route learned through ISIS and the route directly configured. So, and it will change that route from a, but we can see it is going to match both of these, but the second criteria is it's only going to match this one here from ISIS. So this is the only one it's going to modify, and it's going to change it from a level 2 route to a level 1 route. Let's see if we can get more detail on that route. So the command I will use to find more detail on the route is detail, or that's the knob I will use. So, now we can see it's a level 2 route. And here's the preference, is what it's called in Juniper LAN. It's called administrative distance in Cisco LAN. Yeah, so I think this will be important to keep an eye on after we apply that policy. For now, let's skip this and see if I got the the configuration correct for protocols ISIS. Okay, so it looks like I was a bit different, and my difference was that my level 1 disable, I only added to my physical interfaces, and I did not add it to my loopback interfaces, and those were passive as such. All right, I will pause the recording momentarily. All right, and I'm back. So let's see what, so let's see what the difference is. Let's do a show route detail on this on a different router. So first of all, let's take a look at what address that is. Okay, so it's the .3 address. So let's go to a few different routers, or let's just look at them all and do a show route detail and see what the details look like. Then we'll make that change and we'll see if they look different. Okay, so just put this command on all of them. I'll be using Secure CRT during the exam, so I'll have a much easier way to apply it to all of them. But for here, there's just not that many routers in the topology. So we can see on the level 1 routers, it is level 1. Oops. I think one thing I did forget to do though is after I made my commit here, I forgot to go and check that the routing table is different. Oh, okay, yeah. So you can see .3, .4. So now we did leak in all of these routes. So we've got .16 leaked in. We've got .3, .4. We've got .20 leaked in. Oh, I guess .20 isn't leaked in. So I'm not sure what happened there. We don't have .25. So it looks like these two routes didn't get leaked in, but the loopbacks got leaked in somehow with that configuration. Let's try rolling that configuration back and then see that those have disappeared. Okay, so now let's see if these will disappear. Oh, so it looks like it already happened. It happened really fast. So let's roll it back again and we'll see those come back. There we go. So yeah, it happens really fast. You can see this output is different from this output and they're just a second apart. So sub-second update. And yeah, it looks like the only extra routes we got were the, oh, we also got a .16, but that's it. We got, so then after that it's .28 through .36, 5 routes. Here's well, .28 through .36, 5 routes. So we just got this extra .16. Then we got the loopbacks, but for some reason we didn't get these directly connected routes. So I think the reason for that is because I'm only matching from protocol ISIS. So if I wanted these to be leaked into level 1, and you can see right now they're not leaked into level 1. Show route 10.0.0.20. So it's only there via the default route that was sent, but it's not, the route itself is not there. But to add it, I believe I can add protocol direct to this. So I'm going to try to do that. Okay, so now that we've got protocol direct, we might eventually see this change so that it gets the more specific routes instead of the less specific route. But I actually think it actually might not, because it is not a level 2 route. It's a direct route. It doesn't have a level, so it's not going to match that level 2. So I think that's what's going on here. So let's just roll back that configuration and then continue to go through the answer key. Okay, but I got everything for the most part right. I just didn't get this level 1 disable added on there. I just did not think it was necessary, but let's add that on there, and let's go ahead with what we were going to do before and see how that route looks different with that added on there. Okay, so now let's add the level 1 disable. Okay, so give it a moment to propagate through, and then we'll check this route again. Okay, so this is interesting. It looks like it's still level 2, even though, so yeah, all we did is level 1 disable. So yeah, I actually don't expect there to be any differences for this, really. Okay, yeah, so we don't have any differences. I'm surprised it's showing up here. But the reason it is because I have that leaking policy that I came up with myself on router 3. And it appears to be working for the most part. It's just not including the direct routes. So let's kind of keep a scorecard here of the differences between what they have and what I have. So for router 1, they've got these differences. Okay, so now let's move on to router 2, even though I have a feeling it's going to be pretty much exactly the same as router 1. Yep, so it's exactly the same as router 1. This is all the freebie config I've got more than mastered right now. So this is the difficult config, and yep, I did the first thing I did on router 1, which is different than what they did. They put this leaking policy on router 4 for some reason, which is router 2 in mine. So that's still a mystery to me. Hopefully we'll figure that out shortly. Okay, so on to router 3. And this is a bigger one because this is between levels. Wow, okay. So wow, that's interesting. So yeah, you can see there's a huge difference in how they did it and how I did it. So how I did it is I only had my leaking policy on the device that connected level 2 routers to level 1 routers. But what they did is the opposite of that. They only had their leaking policy on the level 2 routers, and then they had no policies on the device connecting the two. So yeah, there's no policy on here. There's just the freebie config, which is the interface config there, and then the protocols ISIS config. And yep, and here I did get this part 100%. I disabled those unneeded adjacencies, and I did them correctly. Well, I guess it doesn't tell you which is which, but I'm sure it's right. And then this is the only difference, except I added a whole policy here that they did not have there. So let's say they did not add a policy here. All right, now let's take a look at router 4. It'll be interesting to see if these have leaking policies on them. I would be really, really surprised if they did, because we know that the default policy does allow for leaking from level 1 to level 2. Okay, yep, and I was correct. There's no leaking policy. This is the simplest, most straightforward config in the example, because it's a level 1 router going to level 2, so those routes are able to be transmitted by default, which of course we can see demonstrated in the routing table of router 1. We have the loopback addresses, but well, this one. Oh, wait, do we not have the loopback addresses? What's going on? I'm confused. We don't have the loopback addresses. Well, where are the loopback addresses? Maybe it's because of my. Oh yeah, okay, yeah. This is what I was. This is why I kind of knew there was something afoot, because I wasn't able to find a way to apply my policy to only one level. And that's what I was looking for. So I applied it to both levels. So we can see, yes, I'm allowing level 2 routes to leak over to level 1. We can see that's very clear if we look at the routing table on router 5. Yes, we've got the routes from level 1. Everything is totally fine there. We can even see we've got a different preference. So it's in a different metric, so it's clear that they are in some way different than this router, than this route. And one of the differences they do have is the level they belong to. So we can see that's very clear. And but here we don't see the ones here. Well, why is that? It's because the policy is allowing it from protocol ISIS, and then it's allowing it from level 2, but it's rejecting anything that doesn't match that. So our default action of propagating routes from level 1 to level 2 has been destructed because it's not from level 2 now, it's from level 1. So this export policy into ISIS will filter out any route attempting to go from level 1 to level 2. So obviously this is not the correct policy to use. Okay, so that's no longer on there. So things are gonna look a lot more familiar. It might take a while for the routing table to update. It looks like it has updated now. So we've got this to represent the level 2 routes instead of those routes specifically what we had before. But we were doing that through a method that was not valid because yes, it allowed for the specific routes to be populated in level 1, but it blocked the routes sent from level 1 from ever being installed in router 2. So obviously that's not going to work. Okay, so let's do the final comparison. So there was one more difference here just with the level 2 disable on the loop back, but everything else was the same. So let's look at the final router. And final router is going to be the same. I don't even really have to look at the config, but I'll just do it for completeness sake. Okay, so yep, that's the only difference. Everything else looks great. All right, so let's dive in a bit deeper to the differences here. And let's, these minor differences, let's go ahead and make those minor differences because I just want to study the policy right now. So if there's some extra problem, I don't want to encounter that right now. Okay, so they did not have a policy there, but I believe I removed mine already. Yes, I did. So the only difference is they disabled level 1 and they did not make it a passive interface, but it looks like I already added that one as well. I just still have this passive interface command, so I will delete that. Oops. Yeah, I'll delete that from router 1. It looks like I'll need to delete that on the other routers too. It looks like I also am having an issue where it skips tabs away from the one I want it to be on, just kind of randomly. And I did figure out in a previous video how to do that automatically. You click it once, click it twice, and hit enter. But it seems to be happening still in ways that are in multiple sequences of keystrokes. It seems like that's just one way to do it. So I don't know what SolarWinds SolarPutty is thinking, but they must think that you really need a shortcut way to get to your first tab. Yeah, normally I use Secure CRT. My new position, I found a way to use the Windows subsystem for Linux and to install Terminator on that. I just Googled Terminator for WSL and I found a tutorial. I was able to set it up and it's nice. Like it's got a little bit of problems, but like I wasn't able to bring my Secure CRT license with me, so I would have been limited to like a number of sessions and stuff. And it's is really nice. Okay, so let's see here. We've got, okay. So, right, so I was going through and I was making sure that all of the little stuff is accounted for. Okay, so this is an interesting one because what did they do? Okay, what did they do? So they on router 3, they disabled level 1 for the loopback interface. They did not disable level 2, and router 3 is router 5. So it looks like they intend for the loopback address to be a level 2 interface, to belong to a level 2 interface. Okay, so yep, that's good. So we've got 2 more to clean up the small details on. Okay, so this one's already cleaned up. So it's now 5:59. So I've only been doing an hour time spends, which usually turns out to be like 45 minutes, but it's been I mean, just doing it as part of my day hasn't been too bad, but I think I think I could end up really getting burnt out and frustrated with it if I just kind of push myself too much. So I think I'm going to end the video here, and then in the next video, so in this video, I assigned myself a grade, went through. I mean, I don't know. I don't think I got a really good grade because I did not know that. But this is a pre-test, so I didn't expect myself to know this already. But I put the routing policy in the wrong router. I left it off of the routers that it needed to be on. And not only that, I ended up blocking all routes from propagating to level 2 from level 1. I disabled the default behavior. Basically, all I did is I flipped it where it is normally the case that routes propagate from level 1, but not to level 2. I set up a policy that flips it so that now routes only propagate from level 2 to level 1, but not level 1 to level 2. So I think that's a big fat F, but luckily it's a pre-test, so it's I think it's a good sign that I'm going to need to devote more time to the final solution than just a quick check, yes or no, did I get it right, did I get it wrong. So stay tuned for that. That'll be the next video where I go through the correct answer here, which is configuring the route leaking policies on router 1 and router 2 instead of just on router 3, and I try to get a good understanding of why that is the necessary configuration. So stay tuned for that, and thanks for watching.